Hey guys, I wanted to make a video for a review for this upcoming test, chapter 1. I'm going in order what I'm expecting to be the thing that people probably most forgot to the things probably most people know. So I'm going to pick more of the abstract parts first and then go through there. So first, let's talk about the parent functions. These are things that are easily forgotten. And when I ask you for this, I'm going to also ask you for the domain and range. So we're going to need to know how to deal with the domain and range. And based off the parent function, what shifts affect the domain and range. Okay, so first one, let's start with this. This is a constant function. This is a straight horizontal line. So in terms of the domain, if you look at the graph itself, it goes from negative infinity to positive infinity. There's no issue here. So the domain is from negative infinity to positive infinity. In technicality, I could plug any question, any number in here, whereas negative a billion or a billion. The range in this case, though, is always just going to be simply the point that is at. So in this case, since the range is just going to be at C, your range is C. It literally cannot be any higher nor any lower. Okay. Identity functions are linear functions. No matter what the transformation is, the domain will be all reals. So from negative infinity to infinity. And the range is always going to be all reals, negative infinity to infinity. Doesn't matter what the transformations are. Now this one, the square root function. This over here is definitely something that people are going to get tripped on. So I don't want you to be that one person. So if you notice here in this picture, there's some kind of restriction on what could happen, right? We know from square roots, we can only plug in positives. But based on the situation, it also looks like it could be shifted here. So your domain could change. So the domain is going to be negative infinity. No, I'm sorry. Your domain is going to be your horizontal transformation. And what your horizontal transformation, let's say x minus h plus k. So if it moved, let's say 2 to the right here, your domain would be 2 to infinity. If it moved 2 to the left, it'll be negative 2 to infinity. So your domain is simply going to be h comma infinity. Your range in this case is how much it moves up to down. For example, if I moved up 3, your range will be 3 to infinity. If you're moved down 5, your range will be from negative 5 to infinity. So your range here is k to infinity. If you're dealing with a vertical flip, so you have an absolute, the square root flipped over, so something like this, where your graph gets flipped vertically. In this case, the domain will still stay the same, which is h to infinity. The thing that will change is that the range, instead of being from, let's say it was here, negative 2 to infinity, notice the highest point it ever gets to is negative 2. So we would describe this as negative infinity to 2. So the flip will occur. If you have a flip, you're going to flip the range. If you have a flip, a vertical flip with a negative in the front, you're going to change the range. Here, for our absolute value, the domain, is there any restriction in what I plug in? No. So from negative infinity to infinity. Oh, if someone will correct me, technically you could put a hard bracket here. My apologies. You could put a hard bracket here. For the absolute value, the domain is infinity, but the range is going to be whatever the vertical shift is going to be. Because if it was moved up here, is everything above 2. If it was moved down here, is everything above -2. So in this case, your range is going to be a hard bracket, k to infinity. So whatever your vertical shift might be, so k to infinity. Conversely, if it was upside down, because you had a negative in front of the absolute value, domain will say the same. The range again will flip. So it'll be from negative infinity to k. The hard bracket on the k. This one, the squared parabola, or squared or quadratic, we sometimes call it. A parabola is going to be the same exact thing as the absolute value. Domain, negative infinity to infinity. No matter what horizontal shifts occur, the domain will be negative infinity to infinity. While the range is going to be from your k value to infinity. Same rule applies if it was flipped over, because it was negative x squared. The domain will stay the same. The range would just be flipped over from negative infinity to k. Cubed is really nice because no matter what you do about it, no matter what the transformations are, the domain is always negative infinity to infinity. And the range could be any result, so negative infinity to infinity. Because no matter how we move this cubic function, it will always hit all the x and y values eventually. It might take a while, but it will hit all x and y values. So it doesn't matter if it's flipped or anything, it will be just fine. Our next one we're going to talk about, which I'm sure people forgot about, is difference quotient. Now, this is the equation for difference quotient. You do not need to remember this equation. It will be given to you on the test. So for this one, we're going to use f of x is x squared plus 4. Let's find let's find what it is with the difference quotient and simplify. So I'm going to plug this in. X plus h is going to go for every x that's here. So it's going to be x plus h squared plus 4 minus f of x. It's just the normal equation. So I'll put in parentheses, x squared minus or plus 4. All over h. Yes, you could distribute right away if you want to, but no need to right now. All right, the top thing I'm going to FOIL, x squared plus 2xh plus h squared plus 4 minus x squared minus 4 all over h. Looks like we can see the x squares cancel out. These 4s cancel out. 2xh plus h squared over h. I could factor out an h. H's cancel out. So your final answer is 2x plus h. So it's simplified as much as possible. Nothing else I could do there. So difference quotient, you will have the equation. It's just up to you to do the math properly. All right, our next thing is even and odd functions. So even functions are reflective over the y-axis, and odd functions are reflective over this y equals x, or f of x equals x, aka the identity function. So in order to test what's even and what's odd, what we do is first plug in. So you get the equation. You first plug in f of negative x and check if they match. So this one on the left, it matches with the original equation. So we know at that point it's even. Let's say if it doesn't match, after that, what you're going to continue to do is if it doesn't match by you plugging in the negative, you're going to factor out a -1. And if the inside of the parentheses match the original equation, then we have an odd function. Let's say you do both and it doesn't match the first time nor the second time. It will be a neither situation. All right, the next thing I want to talk about is transformations. This is going to be for any generic transformation. So it could work for like x squared or x cubed or square root of x or absolute value of x. These are all applies. So in this case of scenario, there's a couple of things to know. First off, the value inside the function is going to be your horizontal shift left or right. But because the equation is negative h, you want to think of it opposite. So for example, I'm going to do this. For example, 3, let's do x minus 2 squared plus 4. So the h value is going to tell you the horizontal shift, but you got to think of a reverse. So instead of -2, it's technically 2 to the right. So 2 right. Actually, I would just write the number. 2 to the right. This number over here, k value on the outside, is going to tell you your vertical shifts, whether you're going up or down. So in this case, you're going to go 4 up. And this a value over here is going to tell you some values in terms of whether you're vertically stretch or shrink. If it's greater than 1, if a is greater than 1, I should say the absolute value of a is greater than 1, then it's going to be a stretch by whatever value. And if absolute value of a is less than 1, then it's going to be a shrink based off the value. So in this case, this is going to be a vertical stretch by a factor of 3. Now, before I think I told you about horizontal vertical stretching or horizontal shifting, I'm sorry, horizontal stretch or shrink, you do not need to worry about that on this test. You do not need to worry about that on the test, so I'm not going to go over that. But that's the basics of transformations. So for this one, I'm going to talk about function operations. You have the standard operations of addition, subtraction, multiplication, division, but you also have the operations of a composite function. So I'm going to go over all that, or I'm going to go over some of them. So for this one, I have x, 3x plus 1, and the g of x is 2x squared minus 5. If you want to pause the video and try it yourself, that's fine. So for these, I'm going to go one at a time. For f plus g of x, all I'm doing is going to do 3x plus 1 plus 2x squared minus 5. You don't necessarily need to put in parentheses, but it just helps so you don't make any mess ups, especially when you subtract and you need to distribute. But here's a very quick one, 2x squared plus 3x minus 4. All right, next one's f times g of x. So 3x plus 1 and 2x squared minus 5. We're going to multiply that. So that's going to be, if you FOIL it out, 6x cubed plus 2x squared minus 15x minus 5. And you always want to check if you can combine like terms. In this case, there's no like terms to combine, so we're done. Now, the composite function is usually the hardest part for people. So when it comes to composite functions, that's a function in a function. So what we're going to do is f of g of x. F of g of x, I'm going to take this g of x, and I'm plugging it in for the function. So in this case, is f of 2x squared minus 5. I replace the g of x with the equation it actually is. And in the same way I replace a number with a number or a variable with a variable, I could plug in a whole equation for an x. So it's going to become 3, and this x over here is going to become the new equation, 2x squared minus 5 plus 1. From there, I'm just trying to simplify. 6x squared minus 15 plus 1. 6x squared minus 14. Pretty straightforward. One thing I guess I should have also put in, let's just do like f plus g. Let's do f plus g of, let's say, 3. If you have an actual number here, you're going to replace each one with a number. So in this case, it will be 3 times 3 plus 1 plus, I should put this in big parentheses, 2 times 3 squared minus 5. So if you have numbers, you're just going to plug in the numbers and do it out. A lot of people find the numbers one even easier, so that's good. So this is 10. 9 times 2 is 18 minus 5 is 13, 23. All right. This one is an easy question. You just have to know how to use the piecewise function. So when it comes to piecewise functions, what we got to do is we have an equation like this, kind of like this big bracket, and we're going to have two parts to it. First is the right side is weird because you go right from left. Right side tells you which equation to use, and left side tells you what is the equation going to be. So where are you going to do it and what you're going to do. So for this one, I have f of -2. So I look at here and see where -2 should be. This is x is less than -2, while this is less than or equal to -2. So this one is going to be this equation. So I take 6 and plug it into this one, which is -2, which results into 12. This one, f of 4, I'm going to look at again. I need where it belongs. And in this case, 1 is greater than or equal to 4. So 4 should be here. So I'm going to use -5 times 4 plus 1. -20 plus 1, -19. Piecewise function is really easy. Don't mess up these points on dumb mistakes on this one. Last thing I want to do is talk about functions, what makes an inverse and what is a function. Remember, a function has one rule. Every input should have one output. So let's say you had an example of this where you had like the absolute value of y. I might turn to black later. Absolute value of y equals, I don't know, x plus 2. Here, in this situation, this is not a function. The reason this is not a function is because here, if I wanted to figure out, well, what causes me, like in this case, what causes me to have a y ended up equaling, let's say I want this to be 4 on the right? What could I plug into the y? And if it's where every input should only have one output, that means there's only one thing I should put where this results. And in this case, I could have a -2 or a +2 into this equation. So in this situation, this is not following the rule of the function, which is every input has one output. So if I were to input, let's say 2 in here, 2 plus 2, that would get me 4, right? And I don't want multiple answers to that. I should have, let me rephrase this. If I want to get the absolute value by itself, it'll be y equals, or the y by itself, plus or minus x plus 2. I should kind of do it more like this. Once you get the y by itself, if you have a plus or minus, and that happens in absolute values, also if it's like y squared or y to the even power, you know in this situation, it cannot be a function. Because what's occurring here is that if I plug in an x, I'm going to get 2 answers. So I cannot have 2 answers. But the real easy way to think about it is y to the 4 for y to an even power, or maybe y to an absolute value power. Okay? So that's what causes it not to be a function. Let's talk about inverses. So what is or is not an inverse. So something like, and finding the inverse. So let's say f of x is 3x plus 2. To find the inverse is pretty simple. We're going to set y equals 3x plus 2 minus 2. Then we're going to swap the x and y's. So x equals 3y plus 2. Now we're going to solve for y. X minus 2 divided by 3 equals y. This is an inverse, and this is totally valid. So we would say f of negative x, negative 1x, or the inverse of function f, is x minus 2 over 3. This is more proper of a final answer. Something that wouldn't have an inverse would be something like this. Y equals x squared plus 3. In this case, what would happen is I would do y minus 3 equals x squared. Then I have to square root both sides. And this is why a couple tests ago, I made it really important to say plus or minus. Oh, I forgot to swap the x and y, so I'll just do that right now. The x here and the y here. So then we're just gonna square root both sides. And remember, the plus or minus is needed. X minus 3 equals y. The same issue as before. When I invert it, I have this plus or minus, which breaks the rule of every one input gives me one output. So because of that, this is not a one-to-one function, and this would be no inverse. So if you have a situation like that, you just write no inverse. All right. All right, I said the last thing was going to be the previous one, but this is the last thing. We talked about transformations, how they move left and right and up and down. In this case, we're just going to also do the reverse, where I give you a graph and you give me the transformation. So first, you need to identify what the parent function version of this is. And you should see the straight lines. That's a v. This is obviously a absolute value. So I'm going to start off my function, knowing it's an absolute value. Now I'm going to see how many horizontally shifts. In this case, it horizontally shifted 1 to the right. So because it shifted 1 to the right, I'm going to put a -1. Remember, you have to have a negative h. So even though it's 1 to the right, it must be -1 because your h value is actually +1. And then you go up 2, so +2. There is, on this questions, these types of questions, you could completely ignore vertical stretches or shrinks. They're too subtle for like your eye to understand without actually just doing all the calculations. But if it was upside down, so let's say if it was like this, if it was upside down, you would put a negative in front. But it's not upside down, so no negative in front. You're all good. This is an answer to the question. This is an equation to said graph. I think that's everything I'm going to cover. If anything I think about, I'll show you on Thursday. Otherwise, good luck on the test. You guys will be just fine.